Hello, good morning students. Today we are going to deal with internal resistance. Last class we already studied internal resistance means it is the resistance inside the cell which opposes the flow of current through it. It is the resistance inside the cell which opposes the flow of current through it. So, what are the factors affecting the internal resistance? First one, larger the separation between the electrodes of the cell, more the length of the electrolyte through which the current has to flow. So, consequently higher the value of internal resistance. So, larger the separation between the electrodes, higher will be the internal resistance. Then, next one, greater the conductivity of the electrolyte, lesser is the internal resistance. So, the internal resistance depends upon the nature of the electrolyte. Then, internal resistance of a cell is inversely proportional to the common area of electrodes dipped in the electrolyte. That means, if we are dipping more, if we dip the electrodes more into the electrolyte, the internal resistance will decrease. And the last thing, internal resistance is inversely proportional to temperature. As the temperature increases, internal resistance will decrease, and if the temperature is decreasing, then internal resistance will increase. That is why it is difficult to start the vehicles in cold times, because the battery will have high internal resistance. So, you will not get the required amount of current to start a vehicle. So, starting of vehicle becomes difficult at cold climate because of high internal resistance. Now, listen, internal resistance of a cell is determined, it is drawn like this. I draw a cell and just closer to the cell, I will mark the resistance and put small letter r. Small letter r stands for internal resistance and capital letter R stands for external resistance. So, this E is actually the EMF of the cell, and when the current is drawn from the cell, the voltage drop across the resistor is called terminal potential difference. When the current is flowing out through the cell, the voltage drop across the resistor or voltage drop across the cell. Across the cell means this, across the resistor means this. These both are same only. That is called terminal potential difference. So, due to this resistance, there is a voltage here, voltage drop, that is V. Now, due to external resistance, due to the internal resistance, there is a voltage drop here inside, that I am marking as VL, V subscript L, where VL is called lost volt. VL is called lost volt, and VL is equal to I into internal resistance. Okay, so the total EMF E can be written as V plus VL, V plus VL, and you already know V is equal to I into capital R, right? And what is VL? I into small r. So, I into capital R plus I into small r, or I can write I into capital R plus small r. So, I is equal to E by R plus R. So, for the current, this relation is called a circuit equation. So, for current we have two equations now. If we are taking EMF, E divided by R plus R. If we are taking terminal potential difference, then V by R. So, remember, there are two equations. Both of them will give the same value of current only. So, if we take terminal PD divided by capital R will give you I, external resistance only. But if you take the EMF divided by external resistance plus internal resistance will give you the current. Okay. So, what is lost volt? It is the voltage lost inside the cell due to its internal resistance. Now, internal resistance of a cell in terms of EMF, voltage, terminal PD and external resistance. So, I am drawing the same circuit which we did before, and this is actually VL. So, EMF E is equal to V plus VL, and I just wrote V plus I into small r. Small r is the internal resistance. So, from there, what is this is EMF E. So, what is IR? E minus V. So, dividing by IR equal to V. So, I am dividing the entire thing, entire equation I am dividing by IR. So, IR divided by capital IR is equal to E minus V divided by V. So, LHS I divided by I into capital R and RHS I divided by V, because IR equal to V itself. Now, I get cancelled, E by V minus V by V. V by V is 1. So, E by V minus 1. So, I will be getting like this, small r by capital R is equal to E by V minus 1. So, from here, what is small r? E by V minus 1 into capital R. Okay. So, this is the equation to find the internal resistance of a cell. So, please note down this. Please note down. Now, we are going to see the combination of cells. First, the cells are connected in series, then the cells are connected in parallel. So, we are going to see why do we connect cells in series and why do we connect cells in parallel. We connect cells in series if we require more voltage. So, please note, cells are connected in series if more voltage is required. And the current, there will not be any change in the current. Current remains same. In series combination, current remains same. Now, when do we connect cells in parallel? Cells are connected in parallel if we require more current. At that time, there is no change in the potential difference. So, just see here, I have just marked 3 cells. All of them are having the same EMF E and internal resistance R. They are connected to the external resistance capital R. Then the total EMF will be N times E. Total internal resistance will be N times R. So, total internal resistance is N times R if there are N numbers. Then there is one more external resistance capital R. So, what is the actual resistance as a whole? NR plus capital R. Now, current I is equal to total EMF by total resistance. Total EMF is NE. So, I is equal to NE by NR plus R. Okay. So, if R is less than NR, then I is equal to E by R. So, when internal resistance is negligible in comparison to the external resistance, then the cells are connected in series to get the maximum current. So, if we need a maximum current, we make the internal resistance negligible. We use cells having less internal resistance. Now, parallel combination. We already told cells are connected in parallel if we require more current. So, in parallel, the current will get added up, whereas the EMF will not get added up. So, consider there are n number of cells, each are having EMF E and internal resistance R. So, the total EMF will be E itself, EMF will not get added up, and In the last video we studied when resistors are in parallel. If there are n identical resistors, Rp is equal to R by n. So, I am using that equation, Rp is equal to R by n. So, what is the total resistance as a whole? The total resistance will be the sum of internal resistance plus external resistance, right? So, R by n plus capital R. Then current I is equal to, you will get like this. Current I is equal to E by R by n plus capital R. Then you have to take the LCM. So, E divided by R plus NR whole divided by n. That n will go up. That is how you are getting an equation like this. I is equal to NE by NR plus R. Okay, that is the equation for the current. Now, just see the conclusion. When the external resistance is negligible in comparison to the internal resistance, then cells are connected in parallel to get the maximum current. So, if internal resistance is negligible, internal resistance is very small, to get the maximum current we have to connect it in series. If external resistance is very small, then we have to connect it in parallel to get the maximum current. Okay. Now, these things we studied when the cells are identical. What will happen if the cells are not identical? Then we have to do separate calculation. Separate derivation is there for that. So, that we will deal in the next video. Thank you.